All right. Hello, everyone. So my name is Alex, and we'll be talking about deploying MySQL Percona XtraDB Cluster in Kubernetes. Um, my name is Alex. I've been working with MySQL, doing MySQL consulting for many years already. Worked for MySQL AB, then Sun Microsystems, then Oracle, and joined Percona in 2013. So, who is using Kubernetes today? Oh, wow, okay. And Openshift out of that? No one. Okay, good. Who is using MySQL? Aha, okay. So, that's good. And who is using Percona XtraDB Cluster? Very good. So, what is Kubernetes? Kubernetes is open source system for managing your containers. And I can tell you then, oh, let me start with this. I have heard about Kubernetes about a year ago. And I was trying to figure out what this is and how it works. But in reality, we have that container orchestration thousands of years ago, maybe hundreds of years ago. Is it? It's a container orchestration in the real world. I make this photo yesterday, actually. That's a Barcelona port. So does it look familiar? That's a sort of container orchestration. All right. So what is Percona XtraDB Cluster? Percona XtraDB Cluster is a synchronous, or I would say virtually synchronous replication using group communication. So PXE, Percona XtraDB Cluster, PXE for short, is for high availability. So the whole idea of the PXE is to provide you the high availability, but also some scalability for reads. So how does it work? It works by using the so-called group communication. That's a part that has been created by Galera. And the group communication will distribute your changes, your writes. You can write to any node at a time, and then everything you write to node 1 will be synchronously replicated to other nodes. So Percona XtraDB Cluster will not provide you the scalability for writes. If you think about that, whatever you write to node 1 will need to go to node 2 and node 3, and will need to be written to all 3 nodes. But it can provide you with the scalability for reads. Now, why am I using the PXE example for Kubernetes? One of the reasons why I'm using it because it's easy to deploy. It's easy to deploy because it supports auto-provisioning. How does it work? A new system with no data will join the cluster. It will know where other nodes are because it's all in my.cnf. And then it will take a backup from one of the nodes in the cluster. It's called donor node. And then it will join the cluster. So all the nodes will be on the same page, basically. They will have the same data in it. So auto provisioning will make it easier to deploy in systems like Kubernetes or Openshift. With auto provisioning with a backup system, we can distinguish between 2 modes. The full data sync, we call it SST, and the incremental data sync, we call it IST. So what's the difference? If one of the nodes will be down for a short period of time, for example, an hour, this is actually configurable. You can configure the Galera cache to store more data, for example. If it will be down for a short period of time, it will reconnect and then sync up the deltas, sync up the differences from the cluster. And then if the node is down for a long period of time, so or that's too much differences to store, or it came up blank, no data at all. It will use SST to basically sync up all the data. All right. Now, what is Proxy SQL? Now, the missing part out of the PXE is a router. PXE doesn't provide you with a router. You have 3 nodes, but how do you know which one is alive? So we need some sort of proxy. And we use HA proxy or Proxy SQL to do that. Now, why Proxy SQL? Proxy SQL is a router, and you probably already heard about Proxy SQL. There have been some talks about Proxy SQL today. But what I will be using today is the Readwrite Split capability. So what is Readwrite Split? Well, we have 3 nodes, right? We want to utilize them, basically. It's good for high availability, it's good for quorum, but we want to utilize 3 nodes, especially for reads. So Proxy SQL is man in the middle. It will process all your queries, and depends upon the queries, we can create a rule or set of rules that will route your queries across the cluster. So the easiest read-write split is that we check the query. If it starts with select, then we do round robin. If it doesn't start with select, then we go to 1 node at a time, basically active-passive in HA proxy terms. All right, good so far? So this is the picture. This is what we usually do with Proxy SQL. We can use Proxy SQL and install it on the same application server. Application server will connect to localhost. And then we will proxy the requests to a specific nodes. We can do a reader and writer. Now, in PXE, there's no specific roles. Each node can be reader or writer. We just create it randomly. All right. So this is what we will be doing. So I will explain more about Kubernetes and deployment modes. And then finally, I will do a demo where I will try to kill a node in PXE and see, and hopefully this whole thing will survive. But let me start with this. This is work in progress. This is under Percona Lab. We have created the repository that will allow you to deploy PXE in Kubernetes. And the deployment is done with the YAML files. Basically, what we do is Kube or OC. I'm using the Openshift origin here. Create, and then you specify your YAML file, and then it will deploy the whole cluster, including Proxy SQL. So this is our goal. This is what we want to do. So we will want to have 3 nodes on Proxy SQL. We will have, 3 nodes on PXE, 1 node on Proxy SQL. Then we have PMM, it's Percona Monitoring and Management. And then we have a backup. So this is our goal. So this is a simple script which will deploy everything. When I run this script, what it will do is it will do OC, create, and specify the file. The file is YAML file, which will declare everything that needs to be deployed. This is a quick overview. First of all, I create the MySQL passwords. Those are passwords that we use to connect to PXE. Then we create the config map. Config map is the way to pass the MySQL parameters to the cluster. We use the config map to basically put a file inside of the Docker container. Then we create a service. A service is a way to communicate with the Kubernetes cluster. And then we create 2 stateful sets. I will explain that later on, but stateful set is a set of pods or set of Docker containers. And then finally, I create a service. again, another service, SQL. So SQL service is basically a IP address, a virtual IP address on top of the pods. So again, stateful set PXE node is 3-node PXE cluster. Stateful set Proxy SQL is 1 node, or we can scale it up to 2 nodes of Proxy SQL nodes of Proxy SQL Docker container. Everything is provisioned in Docker containers here. This is our secret file, secret YAML. So this is where we store the passwords. The passwords are not encrypted. It's base 64. It's just in code. So we create the MySQL passwords that we will be using. So we create a root password. We create extra backup password for the SST, for the backup. And we can create some other passwords. For example, if the application will use some application password to connect to MySQL, then we can put it there. This is how we generate the password with a base 64. So this is, again, this is not encrypted. This is just base 64 encoded. Now we create config map. So config map is the way to pass the parameters. So I'm just passing the InHB buffer pool size. It will be better probably to auto-configure and check the memory and pass the parameter, but it's a little bit harder with Kubernetes. So in this example, I'm just passing this parameter directly to MySQL. And or we can pass any other parameters that we want. We can pass some Galera parameters like Gcache size or something like that. So this is what we have now. So we have we use the command OC get all, and then we see what is currently running. So then the most important part for the application configuration is to see the services. So the service is provide you with an IP address. Now this is simple. It will give you a cluster IP address that's not a load balance. It's just the IP address that the cluster will provide you. It's better to create an external IP address, but this is more about configuring your infrastructure, configuring your Kubernetes. You can configure the external IP address that is visible from another project, for example, if the application will go to another project. But this is what we actually need here. So now if we do OC get pods, then we can see what has been created and deployed here. So Proxy SQL is our pod. So pod is a Docker container. So all here are Docker containers. So Proxy SQL is our Docker container, and PXE node 0, 1, and 2 is proxy container. What is not in this picture is how it's get provisioned, basically. So this is the result of our provisioning. When I do OC create something, YAML and stuff like that, it will finally start creating the stateful sets. Stateful sets are created one by one. So it will first deploy node 0, then it will deploy node 1, and third it will deploy node 2. Now the question for you guys, how it will get the data. For example, PXE node 0, when it's deployed, I can start writing to it right away. But then the node 1 is a different Docker container. How does it get the data from and connect to node 1? Anyone? So the PXE cluster is responsible for that. PXE cluster, PXE is doing the auto provisioning. So when the node 1 has been deployed, has been created, node 1 will connect to node 0 and request the data and synchronize the data. So basically, we'll do extra backup. Then the node 2 will come up when node 0 and node 1 is up and running. It will connect to one of the nodes, because we have 2 now. One of the nodes will be elected as a donor. And then it will synchronize the data from node 1 probably to node 2. And then the cluster will be operational. When the cluster will be operational, it will start the Proxy SQL. So the Proxy SQL will check the validity of the cluster. And when it's valid, it will, and we'll talk about that, it will actually start accepting and configure itself. All right. Going back here. So this is our ports. This is our IP address and ports. So what you can see here is that we actually only have the IP address for Proxy SQL. We don't have, well, the Kubernetes will give us the cluster IP for Proxy SQL only. So you configure your application with this IP address. So you configure and you connect to Proxy SQL because Proxy SQL is managing the cluster and it's basically doing the read-write split through it. So you connect to port 3306 as if it's MySQL, but it's actually Proxy SQL. So then you can also use the port 6032. It's an admin port. You configure Proxy SQL with the commands. I will not talk about that today, but Proxy SQL supports the MySQL protocol for both connecting the application and configuration. Now, when we connect to the Proxy SQL using port 3306, how do we know which node of PXE will go? Well, we can use this trick. We can do select hostname. And select hostname will give us the different hostname all the time. So this is how we know that the read-write split is working. So select hostname will give us the information. Now, what I'm also doing is I'm configuring the Proxy SQL read-write split to be smart. If it will just do select, it will go round robin. But if it will do select for update, that means that we'll need to log something. Then it will go to one node at a time. So this is our test. And this is what I will be trying to do today. And then after that, we'll talk about Proxy SQL and how we configure the read-write split on the cluster. So this is what I will be doing. I have created a very simple script which will determine which node it will go. So we'll go to node, just do a select, and we'll go to Proxy SQL. Proxy SQL will be just choosing one node randomly. So that's, I consider it to be a reader. So that's why I'm doing like a reader. And then another query will be select for update. So I can consider that to be a writer. So the nodes will be changing all the time. And then what I'll do is I will kill one of the proxy nodes, and then we'll see how this will react. So I will try to do, I have this recorded, but I will not be using that. I will be using a real demo, and then we'll see how it works. All right. What? It's talking to Rene something. Okay, let me do that real quick. I'm not prepared to this. It worked? Yeah, I did. Right, demos always breaks. Yes. Really? All right. All right, let me try that. Just a sec. No, it doesn't work either. Yeah? Oh, I see. It worked before, that's interesting. Hmm. Okay, I don't know. What did you do? I tried to change the. Well, I can do use a separate displays. Yeah. Use a separate displays.
Yeah, try that. And then, but if you go to preferences, oh, it's not working now. Yeah, open that. No.
Display preferences. Okay,
The
good.
display preferences, yes. Should go. It seems. Open the preferences.
No, let's try that first.
From that, try that. Okay. Now, if you go to scale,
Yeah, try that.
try the. Hold on, because it takes a moment. Try the first one, 1080p. That worked for me.
Mm. But it worked before, that's interesting.
Yeah, it's weird. Sorry.
Yeah, maybe someone will help here. Her adapter. I'll try adapter.
I can give you, if you have a presentation on what?
No, that's a demo.
Okay, that's not.
Yeah, probably. Let's do that. I don't know where it worked before.
Yeah. Try this.
Just a second. Huh? No, no, it's good.
And open the display setup.
Yeah.
You already did it again.
Mm-hmm.
Remove the mirror. You just okay. You have two. Okay. Something is happening.
Oh, okay. Yeah, no, but I need mirror. Okay, now it works. All right, back. All right, guys. So this is the cluster that has been deployed here. So let's do a quick test. Do a host name. So it's going to node 1 and node 2 randomly. So let's do for update. So for update, always go to node 0. So now I will start this script here. And then we'll display us who is the reader, who is the writer. So the reader will changing from 1 to 2 to 1, and writer will always get a node 0. So now what I will be doing is I will be trying to, again, we have all that stuff. I will be killing node 0. And then we'll see how the Proxy SQL will react to that. So let's find out the node 0 rep. So what I will do is I will do PS. And then this is our node 0. I know that because I have been doing that restart already 2 hours ago. So what I'll do is I do docker kill. So the whole Docker container will be killed. All right, killed. So let's see here. Now it hanged. It's waiting until the new writer will be coming up, or it will wait until the container will be restarted. So let's do OC get all again. So this is, I waited too much because before it should have been status error because it was bad. And then it is starting up, so we can get logs here. So now it should have been done. So MySQL is up and running now and ready for connection. So let's get here. So after some period of time, it will simply start writing and reading from the nodes. So what happened? In this particular case, what happened is the node, the pod, has been killed. When the pod is killed, then Kubernetes actually will restart it. And when it will restart, it will rejoin the cluster, get the IST, get the new information from the cluster, and keep up and running. So in this case, Proxy SQL didn't even elect anything else because it was very quick. In theory, what will happen is that if it will be too long, then Proxy SQL will reconfigure itself to use and choose one additional node, one different node from the pool. All right. So now let me show you how we do the Proxy SQL configuration. So here we have the repository, and this is the deploy, and then here's the images. So we create our own images for the Kubernetes. The reason for that is that we need to configure everything that will use the Kubernetes deployment and order provisioning. So we have here is we have backup image, we have Proxy SQL image, we have PXE image, and we also have a replica set image. So the same thing can be deployed as a replica set. And we have sysbench image as well for testing this stuff. So if we go to, let's start with the PXE image. If we go here, then we have our Dockerfile, and that will basically install the Percona XtraDB cluster from the repository. But then we have the entry point, and inside of the entry point, we actually declare what to do in the beginning. So what we will be doing here is we will be, among other things, we will be creating users. And this is our MySQL, this is our parameters that we specify in the YAML file. In the YAML file, we have, you remember we have this MySQL secret. This is username and passwords, and this is where we actually take those parameters. This is environmental parameters, and create the users based on that. And then finally, we will do some stuff for the backup. Now let's go to the Proxy SQL image, which is probably more interesting. So inside of that, we have the Dockerfile, which will just install the Proxy SQL from the GitHub repository. But finally, we will run the script. The script is called add cluster nodes. How does the script knows which nodes it needs to configure? Well, there are different ways how we can do that. We use this binary called peer finder, and peer finder will use the internal DNS name of Kubernetes and do the basic discovery. So we provide the cluster name, which we'll declare ahead of time, to the peer finder, and the peer finder will give us all 3 nodes that are associated with this cluster name. And then inside of the add cluster node script, we are waiting on the nodes will come online because we now know the host names. We now know the ports. And then we use the Proxy SQL admin interface to configure the read-write split of the Proxy SQL. So inside of the script, we connect to Proxy SQL as if it is MySQL using MySQL command line and run the commands like insert into MySQL servers and then declare the reader host group and writer host group and then put the passwords there, and then we'll do delete from MySQL servers if I need a cleanup, and then we do provision the users. Now, we didn't talk about that, but the users is a different story. You connect your application to Proxy SQL now. So the Proxy SQL is doing your authentication. So we need to deploy the users to Proxy SQL. We can either do that with manually. If we know all our users, we can simply do insert into MySQL users like I'm doing here. Or we can actually sync the users from PXE. There's a tool that we can run to sync the users into Proxy SQL from any MySQL server. And then finally, this is the most interesting part, right? So we are doing the query rules. So the query rules will determine which hosts it will go, depending upon what queries we're running. So select will go to the host group 20. So that means there will be your writer. And MySQL servers, each server is declared to be a writer or a reader potentially. And then if, the select for update go to host group 10, which is a writer. Select, just a select, will go to host group 20, which will be your reader round robin. And then every command should be finished with a load query rules to runtime, and then we'll save it to disk. Proxy SQL uses SQLite to store the data. Now, the interesting question out of this is what happens if one of the server will go down? Well, what I'm using here is I'm using a scheduler. And we have a script called Proxy SQL Galera Checker, which will actually monitor our setup. And it will monitor our setup, and then it will elect one of the new server to act as a writer. So it will reconfigure everything if one of the node is not available, if the writer is not available. So it will specify a reader host group, writer host group, and the log file, and how frequent do we do here. So now I'm doing 10 seconds. We can put it back to, we can actually decrease the time and do maybe 5 seconds. But if we do it, if we specify like 1 second, what I found out it's just placing too much load on MySQL host, because we'll need to constantly request the state of the cluster. So that's basically it. This is how it works. Let me try to get back. Let's see what will happen. Yep, it works. Good. This is how it works, and we did a quick demo to demonstrate how the Kubernetes and Proxy SQL will react to crashing of the node. Another thing is backup. So backup is a different mindset in Kubernetes. So lots of customers who worked with us were saying, well, how do I run a cron job inside of the container? Or how do I edit a file inside of the container? Well, you don't. It's a different mindset. So you don't, unless you're debugging something, you don't connect to a Docker container at all. So what you can do is Kubernetes will provide you with a cron job. It will provide you with a cron job that will be handled outside of the containers. So we have created the extra backup job YAML file to actually start, let's say, every day. And then it will connect to the PXE node or any MySQL server and then do the backup. The restore is a different story. We have not finished that, but the backup is there. Monitoring. You can use the Percona monitoring management platform. We are deploying Percona monitor agent to the container, so it has the ability to monitor right now. We are not deploying the PMM itself for now. Next steps. The currently Kubernetes supports Helm, and this is the demo that I was giving you is actually using the Helm. So Helm is the way to deploy anything, any project inside of the Kubernetes much easier. Because you remember when I did that, I had to create a script, a shell script, which will line by line execute a command OC create -f something. And then the Helm will basically be much easier to do. It will specify, we will specify the values, the YAML file values, and then it will deploy everything. The backup restore is not done yet. We're currently working on that. We will probably need to grab the data that has been saved on the disk and then reprovision the cluster. So that's basically it. The Openshift provides easy deployment of MySQL. It can be deployed as PXE, Percona XtraDB Cluster, or it can be deployed as a MySQL replica set, or you can deploy anything else. Proxy SQL provide the cluster endpoint, because if we just have 3 nodes, and then one node dies, we hard code this node in the application, then just don't. We will need a cluster endpoint, and Proxy SQL is a great cluster endpoint which can implement the read-write split. I think that's all. All right, then it's time for lunch. Thank you.